Hello guys, and welcome back to another video. On this video we'll be looking at electric circuits. Okay, so let's get right into it. So 11.1 says consider the circuit diagram below. This is our circuit diagram. Now guys, before we go any further, I just want us to remember a few things in terms of a series circuit. First of all, we say that here guys, we say this is our cell, okay, and on our cell we find our total potential difference. Sometimes we can call that the EMF. Okay, yes, that's where we find our total voltage, aka EMF. And then we have to remember what a parallel connection does to the current. We say that in a parallel connection, current is what? Current is divided, okay, in a parallel connection, meaning that each resistor will have its own current in a parallel connection. However, in this case, we don't expect the current to be different because the resistors are equal. Okay, they share the same resistance, thus their current will be the same. But if they were different in terms of magnitude or size, then they would have different currents. All right, then we say that in a series connection, we expect the current that flows here to be the current that comes from what? From the main ammeter. Okay, from the main ammeter. So A1 here guys will be the main ammeter where all of the current that is flowing on this electric circuit will be produced. Okay, and then what else? Okay, I think that's just about it. Oh, another important thing, we see here that our switch is open. If our switch is open guys, it means that we are not going to have any flow of current. Okay, there will be no current that flows until the switch is closed. So an open switch means no flow of current or charge, and that means even our voltage, the total voltage, will remain the same guys. It will not change until we close the switch. Okay, that's what I wanted to get out of the way. Now let's get into our questions. So now they tell us that switch S is open, and then we have to write down the reading on the following. Firstly, voltmeter V1. Remember guys what I've just said now in terms of the switch being open. If the switch is open, it means that this voltage will not change. It will remain the same because it's not being distributed yet. Okay, until we close the switch, it's not going to be distributed, so it's going to remain the same. So here our answer will be 24 volts. What about ammeter A1, where we have our main ammeter, where we have the total current of this whole circuit flowing? Well, the answer here guys is that the ammeter reading on A1 will actually be 0 because our switch is open. Okay, while the switch is open, there is no flow of charge or current. Okay, so this means that our answer here will have to then be what? It will have to be 0 amperes. Okay, that's how you will answer that question. Okay, I hope guys it makes sense. Now let's move on to the next question. Now they tell us that switch S is closed. Okay, now that they say switch S is closed, it means our current is flowing. We also guys here happen to have what? The voltage here on our cell, which is the EMF, reducing because it's now being distributed to these resistors and this resistor. I hope guys that makes sense. Okay, now let's look at this question. They say here, calculate the equivalent resistance of the circuit. Okay, the equivalent resistance of the circuit. Guys, when you see the word, equivalent, sometimes you will see the word effective. Let me also write that one down. Sometimes you will see the words effective. Okay, if they say equivalent or effective resistance, they mean find the total resistance. Okay, that's what they mean in simple terms. So let's go about finding our total resistance. So guys, for us to find our total resistance, this is what we have to notice. We have to notice that this connection here is in two ways. We firstly have the parallel connection, and then we have the series connection. The 8 ohm resistor is in a series connection, and I just want to explain to you how do we know all of this. Remember, we said that if our current is going to be flowing like this, for example, it flows from the positive terminal going into the negative terminal when switch S is closed, right? Switch S is now closed, so our current, the main current will be the current will be distributed from the main ammeter. So it will travel, get into the main ammeter, and then the main ammeter now shares that it shares that current. So I'm just gonna show it like this. It will go that way and go that way, get into this first resistor, which is the bulb. Do you see that as my current is flowing, it's not changing direction, it keeps on just going in one direction. But when it gets to this part here, guys, that's when now things get to be different, because my current has to go into two resistors, right? It has to go into two separate resistors. That means it has to now divide its direction, okay, or divide itself, because it's one current, but now there are two resistors that it has to go to. So this means that my current will go into this direction to give this resistor some charge, and then it will also go to this resistor. Can you see that now my current is being divided here? And if my current is being divided, then that tells me that this connection is what? Is a parallel connection, because the current goes this direction and then it also goes that direction. It's not going in one direction. I hope, guys, you understand that. All right, so this means that these two bulbs are actually they are connected in parallel. Okay, the two bulbs are connected in parallel, these two. Now let's get into finding the total resistance. Okay, so the way in which we are going to find the total resistance is as follows. This is 11.1.2. We will say that the total resistance, let's firstly find the resistance in parallel, guys. Yeah, let's do that first. So we'll say resistance in parallel. We know that when we find the resistance in parallel, we say 1 over Rp is equal to 1 over R1 plus 1 over R2, right? That's the formula we use. Then we substitute by saying 1 over 8 plus 1 over 8. Then when we proceed, we will have 2 over 8. If I put this on a calculator, that's what it's going to give. But remember, guys, that this answer has to be inverted, right? This answer has to be inverted. To invert means that 8 has to go to the top and 2 has to go to the bottom. So we will have 8 over 2. And 8 over 2 is what? 8 over 2 is 4, right? So our resistance in parallel will be 4 ohms. What is our resistance in series? Our resistance in series is 8 ohms. So if I'm finding the total resistance, then I will say RT for total is equal to RS, which is the resistance in series, plus RP, which is the resistance in parallel. What is RS? RS is 8, this 8, the resistance in series. What is RP? RP is the resistance in parallel, which is 4. And if I add these two together, 8 plus 4, I get what? 4 ohms. Okay, so that's how you solve this problem, guys. You can start by finding the resistance in parallel. Once you find the resistance in parallel, remember you invert that value, then you then add the resistance in parallel plus the resistance in series to get your total resistance. There's another way to solve this problem. I'm just gonna quickly erase here and show you that other way, but it's more or less the same thing, guys. Okay, so the other way to solve this problem, guys, is a more faster way. Okay, so the other way is to say we are looking for the RT, which is total resistance, and it will be equal to what? It will be equal to the resistance in parallel plus the resistance in series. Okay, then when we proceed, there's this other formula, guys, that helps us to find the resistance in parallel, and it says Rp is equal to what? The resistance at the top, which is R1, times the resistance at the bottom, which is R2, divided by the resistance at the top plus the resistance at the bottom, right? And then we would get our answer. The resistance at the top, if I'm using this formula, guys, now I'm substituting, right? The resistance at the top is what? 8 multiplied by the resistance at the bottom. This is the resistance at the bottom. It's another 8 divided by the resistance at the top, which is 8 again, plus the resistance at the bottom, which is another 8, plus the resistance in series. What is the resistance in series? It is this 8 ohms. So I'm going to put 8 there. If I put this on a calculator, all of it as it is, it's going to give me 4 plus this 8, and 4 plus 8 will give me what, guys? It gives me 12 ohms. So that's another way of finding your effective, or rather equivalent, resistance in this case. Okay, so yeah, that's how you solve that problem. Now we move on to the next one, 11.1.3. okay, so 11.1.3, guys, says we have to calculate the reading on voltmeter V2. Okay, but there's a problem that we have. The problem that we have, guys, is that we don't know what is okay, first let's go to our circuit. Where is the voltmeter on V2? It's found here, right? Let me just erase some of these highlighters. So V2 is found here, guys. Let me just highlight that part, use a different color, yellow. Yes. So V2, guys, is over here, and it's connected to the 8 ohm resistor that is in series. So they are saying we have to find the reading on V2. What is the voltmeter reading on V2 is what they want. So, guys, for us to solve that problem, we need to firstly look at the formula we have to use, and there is this triangle called the magic triangle, whereby we have V, R, and I. So this, let me put it like this. I prefer it this way, guys. I'm sorry. I prefer the I on the other side, like that. Yeah, now it looks a bit normal for me, but it's the same thing. Okay, just prefer it like this. So when I'm looking for voltage, it means voltage is equal to current times resistance. So the formula I'm looking for is V is equal to IR. Now I have to check, guys, on this formula to say what do I need to find the reading on V2. Let's say this is V2. I need to have my current. I need to also have my resistance. Do I have resistance? Yes, I do. The resistance I have is the one on that resistor, which is 8 ohms. Do I have current? That's where the problem is. I do not have current in this case. So I have to firstly start by finding my current. How am I going to do that, guys? I'm going to find my current as follows. So we are now doing this question, right? So I'll start by finding current, and according to this, if I look at, remember what I said that the current that's going to flow here is actually the current that's found on A1, which is the main current, right? We are looking for this current, which is the main current, and the main current is actually what? The total current. So for me to find the total current, it means I have to use what? The total resistance and also the total voltage. Guys, is it making sense? Now let's remember something. Here when we did our calculation, we said the total resistance was actually equal to what? 12 ohms, right? And what about the total voltage? The total voltage is up here, guys. Okay, this is our total voltage. It's this 24 volts. This is our total voltage, the 24 volts. So that's what we are going to use to solve this problem. We'll start by finding the total current. So we'll say IT is equal to VT over RT. Okay, and then from there we substitute. What is our VT? Our VT, guys, remember, is 24 volts, which is the total voltage. What about the total resistance? The total resistance is 12 ohms. And what is 24 divided by 12? It's going to be 2. What is the unit for current? It's amperes, right? Remember, we are not looking for current, but we need it in this case to find V2. Once we have found our current, guys, it means now we have the current and also have the resistance. What is our current? Our current is going to be this one that we just found, which is 2. What is our resistance? Our resistance is going to be the one on the one connected to V2, which is, guys, 8 ohms. So this means I'm saying 8 multiplied by 2, and the answer I get is going to be 16 volts. Okay, so that's how you solve this problem. 11.1.4. okay, that's how you solve 11.1.4. you start by finding the total current, and then after that you find your V2 like that. Okay, I hope, guys, it makes sense. If likewise you don't understand, just go back and your life will be easy. Okay, now let's look at all right, guys, I made a mistake. We are not looking for 11.1.4. it's 11.1.3. my bad. Now we are answering 11.1.4. okay, this one is for that. Okay, this solution and that solution are for 11.1.3. 11.1.4 says, how do the readings on ammeters A2 and A3 compare with each other? Remember what we said, guys? We said they are going to be the same. They are the same. Why are they the same? They are the same because these resistors are equal, and if they are equal, it means they'll also have equal they will have equal current. Okay, they will have the same current basically, because that current will be shared. As you can see, our total current on this circuit is 2 amperes, meaning that when our current gets here, it gets divided, right? So 2 divided by 2, because we have 2 resistors, will be what? Will be 1. So it means this resistor will have 1 amperes, and this resistor will also have 1 ampere. If we add them together, they'll give us the main current, which is 2 amperes. Guys, that is it for this question. I hope it made sense, and yes, if you don't understand, just rewind the video. Okay, don't forget to like and subscribe and share with your friends as well. See you on the next one. Goodbye.